Everyone, I just want to introduce our final project to you, which named Water Chat. And you can see here is our logo. It is watercolor, and we just put our name on it. The idea of our name is inspired by an existing message app, which named Fire Chat, and we just use this tool to flood the network, and that's why we choose the water word. You can see here is our team members. Then let me tell you the idea of our water chat. It is a reliable messaging mobile app which uses wireless mesh networking to enable smartphone messaging without an internet or cell service. The users can connect to each other via Bluetooth, Wi-Fi, or Apple's multi-peer connectivity framework.
By now, you may be wondering why Water Chat is cool. In the next section, I'm going to show you some scenarios when Water Chat becomes useful and how it operates. Firstly, Water Chat proposes an innovative way to communicate with people, to organize activities, and to share photos during location-based events. Examples are protest organization and information sharing among fan clubs during concerts. Further, Water Chat can be really useful when privacy matters. Water Chat operates without traditional network infrastructure, which makes communication immune to monitoring by wireless carriers. As a matter of fact, Hong Kong protesters use this idea to organize their protest actions against government intervention. Last but not least, Water Chat can be a lifesaver when you run out of options. It enables timely communication when data services go down, possibly during natural disasters, and when you just do not have access to internet when you are traveling abroad.
I'm going to talk about the technical part. The idea is to build a mesh network. Everyone can reach each other via multiple relays. That means the intermediate users help forward your message. The network is very dynamic and should be fault tolerant. User may enter and leave the network at any time, so it is required to update the network topology and update the forwarding table in each node periodically. So there are a number of routing protocol which support wireless ad hoc networking. For reliability, it is better to use routing algorithm. However, it costs really high overhead, so we will use a mix of routing algorithm and routing protocol listed on this slide. Then, as a result, for the receiver, he is expected to get duplicate messages. Then we will get better reliability. Then for the wireless communication, we have two options. One is Bluetooth and the other is Wi-Fi. Wi-Fi have larger transmission range while consume more power. They have their own strengths and weakness. So we will use these two technologies to build a peer-to-peer network.
Hello everyone, I'm going to talk some more about our implementation details. So the first one is security. This is a major part of our system and one that we need to get implemented so that users can talk securely amongst each other. So security is a very important feature because users want to talk and know that their traffic isn't being snooped on and read by other people. So we're going to encrypt all traffic that is communicated in between peers. Another important feature that we need to focus on is how somebody finds peers and joins a network. So when somebody wants to join a group or network, they can broadcast your message to everyone in their range via Bluetooth or Wi-Fi or however they can do it. And then this announces their entry into the group. Then once everybody in the group gets this broadcast message, they can now start communicating with the new member. Now I'm going to talk about some of our skills challenges that we are looking to explore. So We don't have any experience with iOS apps, especially not the new programming language Swift. So Apple introduced this new programming language called Swift, which none of us have any experience with. So we'd like to explore this new programming language and use it for our front end and back end development. As far as technical challenges, we haven't done any communication with Bluetooth or Apple multi-peer connectivity framework. So that's something that we look forward to researching and finding out how to do with mobile apps. Also, peer-to-peer is going to be another technical challenge we will focus on. So we will not have a centralized server, and all the information will be stored on the peers and the nodes. So that includes state and messaging. These are our technical challenges that we'll be facing. Thank you very much for your time. This has been our final project demo.